Okay, next problem is on explain the following spectral gas. Explain the following spectral data systematically and reduce the structure of an organic molecule containing carbon, hydrogen, oxygen. The given data are lambda max 278 and 319, IR values around 3070 to 3010, in the range 2900 and in the range 1685, 1605, 1580 and 1450. Proton number values delta 2.1, which is a 3 hydrogen singlet, and 7.5 5 hydrogen multiplet. Then carbon NMR 198 and 137, these two are singlets, and 139, 129, 128, these are three doublets. And at 26, there is a quadret. M by E value is 120, 105, 77, 51, and 43. These are singlet. So coming to the solution, the value 278 and 319 will be indicating the presence of a carbonyl or aldehyde, which is a functional group will be carbonyl. It can be an aldehyde or ketone because it's giving a higher value. Then the value 319, which is corresponding to an aromatic ring. Higher values 3000 and 2000 regions, usually due to the stereoaromatic, and 2900 is due to alkyl carbon hydrogen bonding. Then 1685, this is due to carbonyl. Usually ketonic groups will exhibit in this region. And then the values 1600, 1500 and 1400 again indicates for aromatic ring bending vibrations. And then proton NMR, 5 proton multiplet, 7.5. Usually this 7.5 values indicating a aromatic ring, and it is having a 5 hydrogen. So that means one position. In aromatic ring there is a 6 carbons. In that 5 carbons are hydrogen attached and one carbon is having substituent. Then the singlet 2.1, which shows in the presence of a CH3, because already it is telling it is a 3 hydrogen, so it will be a CH3 group. Then coming to C13 NMR, the value 198 is indicating a ketonic group, and mass is 120. So this is the structure, because here you can see there is a 5 hydrogen atoms, then 7.5 and carbon values in the range 120, and this is a 3 hydrogen singlet, and it has to be singlet. How it will come, it has to be attached to, and the values around 2.1, so that means it is attached to a carbonyl group. So this is a 198 carbon value for the C13, and if you are calculating the total mass value, it is 120, and the fragments we will get the given data. So like this only we are elucidating the structure. Next is deduce the structure of a compound with the molecular formula C3H7NO. So the values are 238, epsilon max is 10500, that's a UV value. IR values around 3400, 2900, 1600 and 1400. Proton NMR values 1.9, 2.7 and 8.13. C13 NMR comes 2 quadrants and singlets, the values at 176. Absorption value 238, and the higher absorption epsilon max, that is indicating a conjugation. And 2900 is due to carbon hydrogen stretching, and 3400 is due to nitrogen hydrogen stretchings, and 1600 is again as corresponding to carbonyl group. And the 2.7, the value proton NMR, which is medial group adjacent to a nitrogen, then only it is giving that like that value. And 176 usually for CO, which is attached to adjacent to amino group, so that will be a CONH group. So the structure is coming like this. If you are seeing CONH group is there, there is singlets, two singlets with 3 proton, that will be CH3. So like this we are reducing the structure. Next is Compound having a molecular mass is 100. The values are 274. Absorption bands already given, and proton NMR values. So here the solution is 274 and higher epsilon max for a conjugation or aromatic ring. Already from proton NMR it is clear around 7.20 to 7.85 values always indicating benzene, and they're only showing a 4 proton signals. That means it is a di substituted. Two positions are vacant that will be attached to any functional groups. And there are two functional singlet groups at 2.35 and 3.82. That is having three hydrogens, so that will be, of course, methyl group with a CH3. So the structure will be like this. Here you can see CH3 is there, COOCH3. So it is adjacent to oxygen. So it will having a value of 3.82. This will be 2.35, and it is a disubstituted because here two hydrogens are doublets. If you are keeping this in a ortho position, doublet will not be there. Two doublets will not be there. If you are keeping in the para position, these two substituents, then one proton in the aromatic ring will be singlet, and we will get a multiplet in other side. So to get two doublets, and we have to place the substituents in the para position. Also, the IR bands at 830, that is a characteristics value for a para substituted benzene ring. I think these three problems are clear for all of you. So we'll discuss more problems in the next classes. Thank you.